Hello again. Parker says
I
hi.
Nope. My mom got to call.
Okay. We're gonna.
Last night I did not really like it because I didn't get to be in the recording.
Yeah, he was mad at me that I recorded yesterday's notes without him. He was. How? Okay. Parker, do you have anything you want to add about angles?
I don't know what an angle is.
Okay. An angle kind of looks
Like what?
like that.
What?
Yeah, we're gonna look at angles in circles. So that's an arc
This is-
measurements.
This is my way of angles.
Oh, very nice. Good job, bud.
It's kind of an angle.
Yeah. Okay. I'm gonna close the screen down so that we can go ahead and look at some angle measures of circles. We've already dealt with it a little bit. We're gonna take it a little bit beyond what we've done before and then go from there. So, you want to say anything else? Okay. Let's get going.
We have a apple seed cup in the.
Yes, we are growing apple seeds. Okay, measuring arcs, angles, and arcs. Okay, so we've already talked a little bit about parts of a circle, what we are, what they are, what we do. And we know that the radius of a circle is a segment that extends from the center to the edge of the circle. So here's a radius, goes from the center to the edge of the circle. And all radii in the circle are the same. So this is the same. We saw that with our equations. We know a diameter is twice the size of the radius. It takes two of them. There's also other segments in a circle we have not yet discussed. A chord is just a segment that has endpoints on the circle. It does not necessarily pass through the center. A diameter is a chord, but it is a special chord that happens to pass through the center. We're going to work with chords here in just a minute and create angles using chords, so I wanted you guys to know what it was I was talking about. An angle is that has its vertex at the center of the circle is called a central angle. So here we can see, here's a central angle. Its center or its vertex is at the center of the circle. It is formed by two radii. That's two radiuses, plural, radii, and it creates this arc from the circle as well. So every central angle has a corresponding arc. So for example, in this circle down here, we can see that angle STU is 40 degrees, and it corresponds with arc SU, which is also 40 degrees. Since every arc is part of the entire circle's value, the arc has an angle that corresponds with STU. And so therefore, the arc's measure is equal to the angle measure, to the central angle. And so that's kind of our big piece of information here, that if we have a central angle, then the arc is going to have the same value. Okay, so that's the big key part right here. We've actually already done this. This is just review here. So here I just have a quick one here. ABC or AC and BE are diameters of the circle, so they go through the center. And we want to find the measures of each arc. So first off, arc AE. So here's AE. We can see that its central angle is 63 degrees, which means that arc AE is also 63 degrees. That's it. That's all there is to it. What about arc BC? Okay, well, if we follow down to the central angle, we can see that this central angle and the central angle opposite it are vertical angles. So the angles are equal, which means the arcs are also equal. And that's kind of something we're going to be working with here in a bit. What about arc AB? Okay, so this arc, we can see it extends, or we could extend it here into the center. And since we have a diameter, we know that if one side is 63 degrees, what would the other side be? Well, the two of them together would have to equal 180 degrees. They are supplementary. So really we could just say 180 minus 63 would give us arc AB, so 117 degrees. And then the last part here, what's the last thing we want to figure out is arc CD. Okay, well, we have a couple of things that we could work with off of there. We know that angle DFE is 90 degrees, so then this angle is also, or this arc is also 90 degrees. And so we want to know what's the last little piece. We've got 1, 2, 3, 4 of the arcs in the circle, we're looking for the fifth arc. So we could add up all of the arcs and subtract them from 180. So we could add our 63 from BC, our 117 from BA, our 63 again from AE, and our 90 from ED, and that would add up to 333 degrees. And so then we could just subtract 360 minus that whole big value, and that would give us 27. So we can see that it's clearly a very small arc. It's smaller than the rest, and sure enough, our value is smaller than the rest as well. So that's kind of how that works. The other kind of angles we're going to look at are called inscribed angles. And an inscribed angle is formed by two chords instead of two radii. And so that's why we wanted to talk about the chord earlier. So there's a chord, two chords. They meet at the edge of the circle, so they're creating that inscribed angle. And every inscribed angle will create or intersect an arc called its intercepted arc. So here we have in the circle at the right, angle F, G, and H. So F, G, and H are all examples of inscribed angles, and they all intersect the same arc, arc JK. So here's arc JK right there. And if we look, we have angle F, or angle JFK, intercepts that arc, angle JGK intercepts that arc, and angle JHK. You see how they all start and end with J and K. So we have the same arcs, or they all intercept the same arc. So what could we describe, or what could we determine about the size of each of these angles? Well, if I kind of take these out, and if I rotate them, I could look and see that, sure enough, they are all the same. Yes. And let me rotate that just a little bit. Boom. So notice that they all kind of overlap, and they are all the same size. So what do we notice about each of the inscribed angles? They are the same size. Okay. So that's something, since they all intercept the same arc, they must also have the same value. What do you want to tell them?
You guys can do this.
Yeah, he's your cheerleader here. Cheer member. All right. So then what else do we know, or what else could we know about an inscribed angle and its central angle? Since an inscribed angle will also have a central angle, so since an inscribed angle always has an arc and a central angle always has an arc, they kind of can relate to each other a little bit. They both have this. What if they both had the same intersecting arc? What would we know about that relationship? So I'm going to erase these and trace them a little bit nicer. So if I was looking, so here is my oops, nope, that's not going to do it. Try it again. Here is my central angle. Okay. And here is my, almost trying to do this as nicely as I can. Boom. Here's my inscribed angle. So we want to know, how do they relate to each other? So if I'm taking my tracing values here, I'm trying to, there we go. That's pretty close. If I take another one and trace it, another one of these inscribed angles, and trace it over, and bring it over here, what happens when I overlap them? Boom, boom. There we go. We can see, and obviously I didn't trace that perfectly, but we can see it takes two inscribed angles in order to create that central angle. So kind of like how we did with our volume of pyramids and prisms and how those relate to each other. It takes two inscribed angles to create one central angle, which means that, so the central angle is equal to 2 times the inscribed, or the inscribed, since it takes two of them, is half of the central angle. So kind of a big topic here, something that makes sense. How do those angles relate? So those are the two big angle topics that we work with. And we can see here then the central angle is equal to its arc and the inscribed angle is going to be half of its arc. So how does that help us? So now we've got just a few quick examples of how this works. So looking at part A, we can see that x is an inscribed angle because it's on the edge of the circle. So that means x is going to equal half of its arc. And its arc right now we're saying is 118 degrees. So what does x have to equal? So x has to be half of 118 or 59 degrees. Boom. And that's really it. So then here on part B, we are looking for the arc now. We can see the inscribed angle. So 41 is the inscribed angle. It's equal to half of its arc. Or we could multiply by 2 to get rid of that fraction. So 82 must be the arc. Okay, what about part C? Now we have two things here. X is the arc, and we can see that its central angle is 56, which means that the arc is also 56. And then how would we find the inscribed angle? Well, the inscribed angle is half of its arc, and since the arc is 56, then y must be half of that, so y must be 28. So there's two values. So here again, same thing. X this time is the central angle, and the central angle just equals its arc. So x is 114, y is the inscribed angle, and the inscribed angle is half of its arc. So y must be 57. Boom. And one more here. So here x is the arc. We can see that the inscribed angle is 28. So the angle is equal to half of its arc. So we would need to multiply by 2 in order to get the arc. So the arc would have to be 56 degrees. And so then we want to know, what is the value of the other inscribed angle? Well, the other inscribed angle intercepts the arc of 56, and the first inscribed angle intercepted the arc of 56. So since they both intersect the same arc, then they must have the same value. Or we could say half of 56, which would give us 28. Two more, last couple of quick examples here. This is kind of what some of the homework's going to look like. So I grabbed two problems here just so you could see them. In circle T, angle SVU. So SVU. So I'm going to drag that down. That's an inscribed angle. So this angle is 43 degrees. We want to know, what is the measure of angle STU, the central angle. So that's what we're trying to figure out. So since the angle is 43, the arc has to be twice that. So the arc would have to be 86 degrees. And then our central angle is going to just equal the arc. So angle STU would also have to be 86 degrees. And that's it. Okay. So then just one more here real quick. In circle P with the measure of angle NPQ. So that's a central angle because that's on the center of the circle. 62 is the central angle, which means that our arc here is also 62 degrees. We want to know, what's the measure of angle NRQ. And so that's an inscribed angle, which is going to be half of its arc. So half of 62 would mean that that has to be 31 degrees. And that's all there is to it. That's all she wrote. So hopefully that makes a lot of sense. And if you have any questions, again, please feel free to ask.